class, right? So you have a public keyword, which is nothing but access modifier, which gives visibility. So basically what we are trying to say here is hello world is could be publicly seen. So it could be seen anywhere within the application. So basically for class level, you have public, which as the name suggests or as the name gives out, it could be seen anywhere within your application. That's a visibility key access modifier. All right, so you have the keyword class here, which is for the class. You need to have it mentioned as class. If you write something else, then it would give you compilation error. So it has to be exactly the same. All right, that's the syntax of it. Hello is nothing but the name of your class. Then you have this public static void main, which is nothing but, as I said, this is the entry point for your application or your class file. So when you run this particular class, it would start off from here. You have a static keyword. Static keyword is nothing but it's at the class level. So basically you need not create instance. We haven't reached to that point yet. So basically hello is a class and you could create instance of hello, which is nothing but object, right? So when you have a static keyword here, you need not create object of hello to run it. If it's not static, then you need to have object of hello created. So basically what I'm trying to say is, say you have one more method here, which is test. Now this doesn't have a static keyword here. So basically what we can do is we can print. So yeah, this is a non-static method, right? Now we cannot call it directly. If it's a non-static, you need to have an instance of hello world created. So basically how you create instance is nothing but hello world. That's your hello world object. So when I say instance, I'm talking about creating object, right? And you could create new hello world. So object of hello world is created using new keyword on static test. Now, whereas the static test need not be called using object. So we could directly call static test. Sorry, I haven't written static here. So this is a static method. Okay. So now you could see here it compiles fine, right? So what I was trying to say is when you have a static method, you did not have an object to call it, whereas non-static method, you need to have object. That's what the static is all about. Then you have void is nothing but the return type. It's not returning anything from here, so that's why it's void. You have main method, that's the keyword, that's the entry point for your application. You have this arguments. You can see string array of strings, which are arguments provided to a particular program. So you could pass on as many arguments as you want. Or if your program is, say for example, you want to pass your name as an argument, you can do that. So this is arguments. Then we have main, which represents startup of the program, which I already mentioned. Then we have system.out.println is nothing but the print statement. So as I mentioned, system is nothing, everything could be thought of as a class. System is a class, out is an instance variable, and println is a method within out. So basically you don't have to think much about it. Just to understand the structure of it, just to understand how a particular class is being written, this is what we have. This is how we write a class, right? Again, just to brief on this, you have access modifier, which denotes the visibility of a particular class. You have the class name, you have the main method, which is nothing but the entry point for your class. You have a static method, which says whether you need an object to call a particular method or could be called directly from a class. You have a return type here. So this is how typically any method would be written, and you can write whatever statements you want to within this particular method. In this case, we have printed out hello world. So basically you could follow this when you do it on Eclipse. So it might be a bit different based on the Eclipse version that you would have, but it should be pretty much similar. All right, so you create a new Java project. So I showed this already on IntelliJ, which is also widely used IDE, but yeah, you could use Eclipse as well. So basically, you could see the project name being written as Hello World, right? And here it mentions the JRE to be used. So here you can see class being created. And let's see how we can run this. So we compiled it and we saw that dot class file was created. Now we can run this. So as I said, main is the entry point. So it would start running from here. So your program control would come here. And the first thing that it would see is you have printed hello world. So it should print this one. Then I would keep it simple. I don't want to, let's see what's been printed here, right? So you could see here hello world being printed first, right? This is where the program execution started from. So it came to main, saw hello world, it printed out hello world. Then you gave a call to this non-static method. So it printed non-static method, which has been printed in this particular method. And then it gave a call to static method, and you could see static method being printed here. So one thing to remember is the program execution starts from main, and it just executes this main method. So whatever content you want to write, you would basically write it in the main method. So you could see here hello world being printed out. Now let's see how easy it is to code the same in the J shell. So J shell is nothing but shell prompt that was created in Java version 9. Since 9 you would have J shell. So since I have Java version 12, I should have J shell as well. So yeah, J shell is nothing but a prompt. So it's nothing but instead of writing into integrated workspace, you could have J shell and you could try out something here. It's not something for production use as such. It's basically to test something, right? You as a developer could, if you want to see what it does, instead of writing everything into the main. So if you write a class, you would have to write things into the main and then run it and stuff like that. With J shell, it's just a kind of interpreter wherein you could write something, some command, and see what the output is. So basically, you could say, for example, we printed hello world, right? So system.out.println hello world, right? If you remember, this is what we typed into our main method, right? So if you want to run this, you have to have all these artifacts created as is, right? To have a class, you need to have main method and then build the class and then run it. Basically in JShell, you could run it just to see what's output, right? As I said, this is not an application as such. This is just for the developer to test what the output for a particular command would be. And what are modifiers in Java? So one thing that we saw in the program was access modifier. We already saw about actually is this one, right? Public, and we saw public here as well. So these are nothing but modifiers, right? Public, as I said, this public means it's an access modifier, which shows that hello world could be accessed anywhere throughout your application. So here we can see it's a word or a phrase, changes meaning of other phrase in some. So basically it's just trying to say that one of the aspects or one thing that access modifier could be used is to control the visibility of a particular class or a method as well. We have an access modifier for your methods as well. So this is just one of the things, right? We would see other modifiers as well. Modifiers in general has some other things as well, but when it comes to access modifiers, it basically controls the visibility of a class, visibility of a class or a method. Or so yeah, modifiers here, as you could see, there's access and non-access modifiers. Let's see access modifiers. So we used public already. So this one is nothing but a access modifier, which is public, which says that it could be used throughout the application. So visible to the world, as it says. Public is nothing but visible to the world. If we talk about chronological order, if we talk about the visibility, so default is visible to the package. So default is nothing but within the package, it would be visible. So basically you could default is without any keyword, without any access modifier. That's a default scope. So within the package, it would be accessible only within the package. So you have like com.edureka, that's your package, right? So this hello world would be accessible if it has a default scope, it would be accessible only within com.edureka. If you try to access it from some other package, you would get an error. So that's the default visibility, visible to the package. Private is nothing but it is visible to the class. It is only visible to the class. So this is the lowest visibility, only visible to the class. If you try to access it from outside class, even within the same package, you would get an error because you won't be able to access it. It is accessible only within the class. Public is accessible to the world. It could be accessed from anywhere within your application or anywhere within your wherever your class file. So basically, if you have a jar file, but what I'm trying to say is public is accessible anywhere, right? Protected is again visible to the package and all the subclasses. So we'll talk about subclasses. So subclasses is nothing but in C we have inheritance, right? Say for example, integer. Integer is a class. So as I said, in object oriented paradigm or in Java, everything could be visualized as a class. So integer itself is a class, right? So there's a number, there's a superclass which is number, which has all the common state and behavior that a particular number would have, right? So number is a superclass, and you have subclasses like integer. A float would be a subclass of number. Long would be a subclass of number. Basically, this is inheritance, right? You are inheriting integer, float, long, double, and everything from number class. So number is a superclass, and all this integer, float, and everything is a subclass of number. So when it comes to protected, it says that it is visible to the package and all the subclasses. So just to keep in mind, as of now, you can think of access modifier as visibility of a particular component, or could be visibility of a class or visibility of a method or an instance variable as well. This is what drives the encapsulation factor of object-oriented paradigm. So basically, we control the access for all these components, or we control the access of class, variables, methods, and everything, which makes it encapsulated. Cannot be breached, sort of. As we could see, this is like I could make this one as default as well. All right, so this is default scope. It would still run because it's within the class. Right now, suppose I make this one as private, right? Just to show you what this encapsulation is all about, or what this access modifier is all about. Suppose I make this one private, right? Still this one runs because it's within the class. You're trying to access it within the class. Now I create a new class. Say for example, we say access modifier test. So I create a main class here again, main method. Now suppose if I try to run this, right? So basically I create the same stuff here. Say I create a hello world object. Okay. Now this one is private, right? Now if I try to access it from here, what I was trying to say is if I, so as you could see here, it says that non-static test has a private access to hello world. So you cannot use it from outside. That's what I was trying to say. So basically, since it has got a private scope, you cannot access it from other class. And if I remove this private now, which gives it default scope, and as we said, default is nothing but it has got access within package. You could see this error going off here. Now it is accessible, right? So that's what it is all about. When you have a private scope, it's within a class, whereas default is within a package. Public is accessible anywhere, and protected is visible to the package and just the subclasses. So let's talk about non-access modifiers. This is not controlling the access of class, method, or variable. When it's static, you need not create object of a class. So basically for static test, you could see that we didn't create object of a class. We didn't call static test on a particular object of a class. It could be called directly. That's what static is all about. The static modifier for calling methods and variables without an object to which it belongs. As we saw, we didn't create an object of hello world. We directly call the static method. Final is nothing but you can't change it. Final, as the name suggests, you can't change it once it is created. So finalizing the implementations of classes, methods, and so this is nothing but instance variable, which we would be talking about the slides to come. Just to tell you, this is an instance variable which we have assigned the value 10. Now suppose within this particular method, I try to change the value to 11. You would get an error saying that cannot assign a value to a final variable. So final is like it's final, can't change it. Once you have created it, you can't change it. But if I remove this final, you could see this error would go off. You don't see this error anymore. Whereas by putting final, you would see this error. So that's what final is all about. So basically, this is good enough for constants, right? So if you have constants within your class, you would make it final so that no one can change it. Abstract is nothing but you could mention it as abstract when it doesn't have implementation of all the methods. So what I'm trying to say is abstract modifier is again a non-access modifier, and what it tries to say is, say for example, you have a shape class. Shape class is an abstract class because shape doesn't say you want to calculate area of shapes. So basically shape class by itself wouldn't know what the area of the shape would be. Shape is a class wherein it's a generic class. It doesn't know what the implementation of area would be. For square, it would be side square. For rectangle, it's length into breadth. Or circle, it's pi r square. So basically shape by itself wouldn't know what its area would be. But now shape is a superclass, and say you have subclasses of it, like square, you would have circle, and so on. So now basically you want to ensure that when you create a subclass of the shape class, you want to ensure that that particular class implements the area. That's when you create it as abstract. So the shape method would have, or the shape class would have area method as abstract, which would be implemented by the subclasses, which has to be ensured. It's kind of ensuring, or if the subclasses don't actually implement it, you would get a error. So basically circle would have its own implementation of area saying pi r square. Square would have its own implementation saying side square. So basically what I'm trying to say is area is a abstract method for shape class. And when you have an abstract method, the class itself is abstract. So you have like shape com.edureka.shape. I'm creating a class. Now I'm creating an abstract method. So when you say abstract, you don't have to provide implementation. It's just a generic this thing. You don't have implementation of it. You just have the signature of it. So basically, as I said, when you have an abstract method, the class itself should be abstract. So we'll have to make this abstract as well. So you created a shape class which would have an area and which would give you this thing. So basically, if you want to have subclass, I don't want to show how the subclasses are created at this point, but basically this is what abstract is all about. You don't have the implementation of it, but you're ensuring that subclass is implemented. So here you can see it's just a signature. You don't have implementation unlike this. Implementation is nothing but if you write something within these braces, this is an implementation for this particular method. Whereas in shape class, you just provided the method signature, but we don't have implementation of it. So that's what abstract is all about. Synchronized and volatile is much about it's used in threads. Synchronized is we are saying that only one thread could get a control at one point. So as we said, threads are nothing but parallel execution. You could have thread, say for example, you could have thread one calling a method. So we have a non-static method test, right? Say this is a method. So what we are trying to say here is if it's synchronized, we can make this as synchronized, private synchronized. So this is what ID is all about. So when you have this integrated development environment, you don't have to type everything. When you type SY, you could see synchronized coming up here and you could select it. So when you put a synchronized here, what we are trying to say is only one thread could access it at a given point. Only one thread at one point. So if multiple threads are trying to access it, one thread has to wait for it. So only one thread would get an entry to this and the other thread should wait for it. So that's what synchronized is all about. And volatile It's basically for memory visibility, or what we are trying to say is, so basically every processor has got its own cache. So what we are trying to say is, when you use a volatile access specifier, don't store it in cache, store it directly into the main memory, so that all the threads would get the most recent value being assigned to a variable. And also volatile is not needed when you have using synchronized as such. So it's mutually exclusive. So let's talk about variable. So variables are nothing but it's a holder, right? It holds value, and variables are nothing but it's reference to that particular or it's a address or something that is pointing to a memory location where the values are being stored, and you could access it using this particular variable name, or you could access the memory location where the value is stored using a variable name. What I'm trying to say here is, so this is a variable and you could access, so this 10 is stored somewhere in the memory, and you could access this part of memory location where this 10 is stored using this variable, or you can manipulate it as well, you can change the value. So basically there are three types of variables in Java. There's local, instance, class, or static. Local is nothing but local to your method. Whenever you have a method or you kind of create a variable within a method, that is nothing but local scope, which is like it has the access, its visibility only within that particular method. Once control goes out of this method, you can no longer access this particular variable. That is local. So if I define something here, say for example, I define something here. So this is a local variable since it's defined within a method. So once the control, you would have this only within this particular method. Once the control goes out of this method, this is no longer accessible. Basically, this is where garbage collection for Java is useful. Once your control goes out of this particular method, garbage collector would kick in and would clean up this variable or clean up this particular memory location, or would make it available for use. So that's the local scope. The next one is instance. Instance is nothing but something that is defined at the instance level. So this is instance variable. So since it's at the class level, right? This is, you could see it at the method level. This is at the class level. So this is nothing but an instance variable. Now there is static variable as well. So this is how you define a static variable. So instance variable is nothing but it's per instance. So you could go and change this instance variable to something else. Suppose I assign a value 40 here. Now I could have one more object created. Suppose I call this object 1 and I have hello world object. So I create one more object here. So what we are trying to do is we are trying to change the instance variable through objects. So basically this is what it is. When you have an instance variable, normal instance variable, which is non-static, you could access it through objects, right? So through object one, you assign for object one, you assign instance variable value to 40. For object two, then you change the instance variable value to 50. I won't say changed it, but you assigned it. This is how you deal with instance variable. It's at the instance level. It's at the object level. Whereas for static, it's at the class level. It's one per class. It's not one per instance. It's one per class. So basically what you can do is you could do something of this sort, wherein it's at the class level. It's not at the object level. You are assigning value 100 to a static variable. So as you could see here, it's not a particular instance that you're operating on, it's the class directly. Just to give you a gist, we have local variable, which is within a particular method, and scope remains within a method. Once the program control moves out of this particular method, Java would or JVM would come in and kick in garbage collector to clean this off. It's only accessible within this method. You have an instance variable, which is at the class level, but it's non-static, and which means that it has copy per object. When you have multiple objects, you could change the values the way you want per object. Static is nothing but one per class, and as you could see here, we changed the value of the static variable to 100 through class. So that's about variables. We have an instance. So instance variables are declared in a class when the space is allocated I'll just read through this one. So when a space is allocated for an object in the heap, a slot for each instance variable is values created. We had a integer instance variable, and whenever you create, but basically an instance of a class is created in a part of a memory which is called heap. So whenever hello world object is created, a slot for this instance variable would be created as well. Instance variables are created when an object is created with the use of keyword new, and destroyed when the object is destroyed. So unlike local variables, which is within the method scope, instance variable is within the class scope. So basically, whenever you create an instance of a particular class, your memory would be allocated for that particular instance variable. And whenever it's destroyed by the garbage collector, it would go off. Access modifiers can be given to instance variables. You could have like private, public, protected, default. All the access modifiers be assigned to an instance variable. So basically, you could have it as private. Private is just within this class. You cannot access it outside this class. You could have public as well, which is like could be accessed anywhere within this application. You could have protected, which is like within the package or the subclass. And you could have the default one, which is nothing but package access, which would be accessible just within this package, that is com.edureka. So instance variable have default values. For numbers, the default value is 0. For Boolean, it is false. And for object references, it is null. So values can be assigned during the declaration or within the constructor. You could assign values directly while declaring it, something like this. Instead of 0 is the default one for integer, as they have mentioned. But yeah, you could assign, if you put it as 10 here, it would be taken as a default value instead of 0. Constructor is nothing but a method which constructs an object of a class. Values can be assigned during the declaration or within the constructor. Instance variables can be accessed directly by calling the variable name inside the class. However, with static methods, when instance variables are given accessibility, they should be using fully qualified name. So what we are trying to say here is this is a static method from which we are trying to access instance variable. In this particular static method, you need to have object reference. This is the object that we created. So object reference dot instance variable. You need to have, as we have mentioned here. So here, as we can see, object reference dot variable name. You need to have fully qualified name. When you try to access it within the static method, you need to have fully qualified name. Whereas here within a method, which is non-static, this is non-static. Here I can access instance variable without object reference. So here, as we can see, it could be accessed without. But if I do it here, it would throw me an error. It's not accessible here at all. Non-static field instance variable cannot be referenced from static context. Instance variables are not accessible directly here. It has to have fully qualified this thing, which is object reference dot instance variable. Whereas when it's called within non-static method, you could use it direct. So static, as we spoke about, it's one per class. So it's declared using static keyword. So static variables are stored in static memory. It is rare to use static variables other than declared final and used as either public or private constants. As we said, it's mostly used for constants, and static variables are created when program starts and destroyed when the program stops. So one thing to remember is it's one per class. It's not one per object. Instance is one per object. You have a copy of that particular instance variable, one per object case of instance, whereas case of static, it is one per class. So the scope remains, or the life cycle remains, right when the class is loaded till the program is stopped, till the class is unloaded. Static variables are declared public since they must be available for users of the class. It's not mandatory though, but usually if it's a constant, it is declared as public. Static variables can be accessed by calling with the class name. So we saw here class name dot static variable. So how do we decide what amount of memory is to be allocated? So these are the data types that we have. So each variable in Java has a specific type which determines the size of memory, the range of values that can be stored, and the set of operations that can be applied to the variable. Data types can be categorized into two major types, primitive and non-primitive. So basically primitive is not object. Primitive is supported by language itself, which is kind of, it has got eight primitive, or it's predefined by the language and named as keywords, and it has eight primitive data types, that is byte, short, integer, then you have long, float, double, character, and boolean. This is pretty much similar to other programming languages that you have. Byte, it consumes one byte. These are eight primitive data types that are predefined. Non-primitive is nothing but string. String is a object itself, so that's something that is non-primitive. Or if you define your own class, say student for that matter here, right? We have defined student class, that's non-primitive. So the student class is non-primitive. We have strings for storing string, which is again kind of non-primitive. We have arrays, or basically it's all called as reference variables, since we're referencing a particular memory location through variable name. This is where we have table showing byte consumes one byte and its range is from -1 to 8 to 1 to 7. Short is like 2 bytes, and you could imagine that it would be from -3 to 768 to 3 to 767. So it's pretty much similar to other programming languages that you have, like in C as well, we have similar to this thing. One thing is character takes 2 byte, in C it takes 1 byte, I believe, though it doesn't use all the 2 bytes every time. It depends on encoding type. So Boolean is 1, which is true or false, since it has to store 1 or 0. So yeah, it's pretty much similar. So just to talk on the bytes required, byte is 1 byte, short is 2 bytes, integer is 4 bytes, long is 8 bytes, float is nothing but it has decimal values stored, signed decimal values. So it again consumes 4 bytes. Double is signed, again float values or signed decimal values, which consumes 8 bytes. Character is 2 bytes, and Boolean is 1 bit. So basically, to decide whether to use float or double depends on the nature of the application. So if you want to have more precision or if you want to have more range, you could go with double. So non-primitive or reference data type is a variable that holds a particular object or holds bit that represents a way to access an object. It's a pointer to a memory location basically. So as we spoke, Java doesn't expose the pointer directly. It doesn't give you directly pointer to the memory location, but it gives you the reference variable. So you cannot manipulate memory location directly. You cannot add some values to the memory location through pointers or something, but through reference variable, you can access it and assign some value. So yeah, it does not hold the object itself, but it holds a reference address to the object. The reference type does not have size or bit range. So here we can see string str is equal to edureka. So the one shown in red is actually the memory where edureka is stored. You have a reference and str is the reference to it. So here we can see variables and data types. So we have a main method again, and we have byte. We declare a byte here. Byte b is equal to 10. Short s is equal to 20. So I think it's pretty straightforward. You kind of have this data types created. You just have to assign values to it. These are all primitives, as you could see. Till here it's primitive. So you could see that values are being assigned and it's been printed out here. So I think it's pretty straightforward. You can assign a value to a variable and just print it. So again, we use system.out.println for printing it. You could try it out on your own. You could try it out this data type program. You could just assign something and just try to print it out. We are talking about data type conversions. So we have implicit and explicit conversions. In some case, programmers don't have to actually write explicit conversions from one data type to other, but in many cases, programmers need to. So the arrow in the diagram shows the possible implicit type casting that are permissible with primitive data types. It's just with primitive data types, right? As the diagram shows, int can be converted implicitly to long, float, double. Since int takes less space, it could be applied to any of the numbers. For vice versa, they have to be converted explicitly. Whereas if you want to convert long to integer, you have to mention it explicitly. So basically, we are talking about when you're trying to store integer into long, integer takes less space and long takes more space. So it can be easily accommodated. Since long takes more space, if it is more than the range of the integer, it wouldn't know how to assign it to integer. So that's why it has to be explicitly converted. Implicit conversions, we can, on the J shell, you could type this. So here what we are trying is we have a character C is equal to A, and you could see C is assigned A. Now integer K is equal to C, which could be done. You could assign character to an integer. So basically it's a ASCII code for it. So 97 is the ASCII code for C, which would be assigned to K. So now when you assign C to float, which works as well, so you get 97.0. You could assign character to long as well, which is 8 bytes integer. You could assign double as well, which is 8 byte float, and you could see. But it cannot be done the other way around as we spoke. So you cannot have integer or you cannot have double assigned to character. So it would give you incompatible or possible lossy conversion from double to character. It has to be explicitly done if you want to do that. Need of type conversions. So here we have integer a equal to 100, initiated a variable with type integer. Then you have a string b, which is assigned value hello. So basically here you can see string being used, which is a reference variable. And you have string s is equal to a plus b. S equal to a plus b, then it adds up like 100 plus. Since hello is a string, it would concatenate it. So you could see 100 and hello being concatenated, and you could see 100 hello. The data type of both the variables are different, but to perform any operation, we need both the variables to be of same type. Here, integer value is converted into string and gets concatenated with other string. So basically, had b been an integer, you would have got addition of it. Say, for example, integer b is equal to 200, and if you 100 plus 200, you would get 300. But since it's a string in this case, 100 is converted into string and it's concatenated with hello. Explicit type conversions. We saw the previous case wherein double was being assigned to character, which prompted us with lossy conversion. So this is similar to that. So basically here what we are trying to do is we are trying to assign double to integer. So you have double, d is equal to 45d, which is 45, right? Again, double is 8 byte decimal signed decimal number. So you assign 45 to it. And now we are trying to assign this double value to integer. So it's possible lossy conversion. But you have a provision to typecast it. So basically what we are trying to do here is you're trying to assign again double to integer, which is possible if you typecast it. So when I say typecasting, it's nothing but opening parenthesis, then the destination data type, then your data, actual variable. So basically to the right side, you could see that through explicit typecasting, we can assign double to integer. So casting may lose information. For example, floating point values are truncated when they are cast to integers. Example, the value of d, that is 45.5, when converted to integer gives 45. So we could see here in the bottom, like the double, we assign the value of 45.5 to double, but when we converted into integer, we got 45.5 was truncated. Since integer, since the destination data type that's integer doesn't store decimal values. Now this is like type conversion methods, which is there in your wrapper classes. What we are trying to do here is we are trying to convert 23, which is string, into integer. So you have a string s is equal to 23. You assign the value 23. So mind you, this is string right now. We have integer dot parse int, and we pass the string, which would be converted into integer. So this integer class that you see here, right here, is nothing but a wrapper class. You have string into integer, which is nothing but integer dot value of string, which converts it into integer data type itself. So as you could see, the destination is integer. Now integer to string, you have integer. We have a toString method which converts integer into string. So basically you have integer I which has been assigned 23. Now you have integer dot toString I which would convert this integer into string. We have one more method which is string dot value of, which would also convert integer into string. Let's talk about operators. Operators are nothing but it operate on these data types. So you have unary, which is kind of pretty much similar to what you have C, C++. You have postfix and you have prefix. Postfix is I++ or expression++, and the operator is after the variable, which means that it would be assigned value and then it would be added. Prefix is before the operator, which would be added first and then assigned, or the operation would be done first and then assigned. That's prefix. Arithmetic is pretty much similar, like multiplicative. You have like multiplication, division, and mod. You have additive, which is plus and minus. You have shifting operation, which is bits shifting to the left and bits shifting to the right. You have relational operators, less than, greater than, less than, equal to, greater than, equal to, instance of quality, quality of two data types or two variables, which check whether they're equal and not equal. We have a bitwise and bitwise XOR, bitwise inclusive OR, which is happening at the bit level. We have logical and logical OR. So basically this is for conditions, right? If you want to have like two conditions, like if int I is greater than 0 and int j is greater than 0, sort of you add or you have logical ANDing between two conditions, logical conditions. Or logical or pretty much similar to other programming languages, like it's or between two conditions. We say that either this or that. We have a ternary operator which says that if the condition matches, we would have a condition followed by question mark followed by colon, and we would have some value followed by colon followed by some other value. So what we are trying to say here is if the condition is true, assign value 1. If the condition is false, then assign value 2. So instead of having it written in if else, you try to put it within ternary operator. So basically this is when you have simple assignment operator. If you have a logic, if you have some particular logic being written, it would be a better practice to have if else so that it's readable, right? Because ternary operator, it would be very difficult to actually read through. We have assignment operator, which is equal to, which is plus equal to, is nothing but adds the value on the right hand side to the left hand side and assigns it to the left hand side variable. Minus equal to does the same thing. It kind of subtracts value to the left hand side from the value to the right hand side and assigns it to the left hand side. So I believe this is pretty much similar to other programming languages. There's nothing different in this. We might have used it somewhere or else. Should be pretty much simpler for you guys. So let's see unary operator example wherein x is equal to 10. So you could see x being assigned value 10. You have x plus plus. As we said, it assigns first and then increments it. So you could see value 10 here again. So now if you, after this, if you print the value of x, you should see the incremented value, that's 11. So that's post increment. So let's see pre-decrement. So you have a been assigned the value of 10. All right, now you do minus minus a, which is pre-decrement. You would see the value 9 directly. And now if you print the value of a, it would be 9 again. So basically this is like decrement and then assign. This is like assign and then operate. This is like operate and then assign. Let's see the negation operation. Like a has a value of true. Now we negate it and assign it to the variable d, and you could see that it's changed to false. Now let's see the arithmetic operator. You have b which has value of 20. We have d which has value of 30. So when you add it, it gives you value of 50. When you multiply it, it gives you the value of 600. 30 into 20, which is 600. When you divide it 30 by 20, you get value 1. And when you have mod, which is like remainder, which gives you value 30 by 20, which is equal to 10. Shift operators, so it shifts to the left. So shift left, shift right. So basically you have integer value of 20, and if you convert this into binary, if you convert the 20 to binary, which comes out 5 digits, right? So when you convert this binary and when you shift it to the left, you would get the value of 80. So you have value 20, which is nothing but, if you convert this 20 into binary, which would give you 10100, right? Now what we are doing here is kind of shifting it to the left by 2. This is what you do, and this is what it shows up as value of 80. So this is nothing but 64 plus 16. So that's what this left shift does. Basically it's shifting to the left by 2. Again, you could have shifting to the right by 3, which would give the value of 2. Just shifting to the right by 3 would be something like this, right? So yeah, basically it shifts it, and you could see that, yeah, basically it would end up to 2. So now we have like relational operators, which is pretty much simple, like a less than b, it gives false. A greater than b, a equals b. Since you have a is equal to b, in this case we have a equal to b, that's why we have a less than b as false and a greater than b as false, but whereas a equal to b is equal to true. We have arithmetic operators, pretty much similar. Basically you have add, you have multiplication, you have division, you have mod. So here we have a is equal to 20. So what we are trying to do is assignment. So a is equal to 20. Now b is equal to 40. A plus equal to b, which is nothing but, as I said, your left hand side would be added up to the right hand side and would be assigned to the left hand side, which is nothing but 20 plus 40 would be assigned to a. So when you print a, it would print 60. Ternary operator, which is nothing but if a is less than b, here we can see that if a is less than b, then the value of 100 should be assigned to tr, or the value 200. In this case, the value 200 is been assigned. A is greater than B. Logical operators is nothing but ANDing and ORing of conditions. Yeah, here we are saying that A is less than B and D is less than B, then return false. And it's like kind of ANDing logical conditions. Now let's talk about the control statement in Java. Now again, this one is pretty much similar to other programming languages, nothing different in Java. So you have control statements, you have iterative statements, you have jump statements. So one is selection or decision making statements, which is like if else ladder. You have if this particular condition satisfies, do something, do some execute group of statements, and if it doesn't, then execute other group of statements. That is about if else. Switch is nothing but based on the value of a variable, like you execute different step of statements. Like say for example, you have you write a switch on integer variable x. Now when x is 1, you do something, or if x is 0, you do something. Or you can have a default statement as well. When x is neither 0 or 1, do something else. That's about switch. Iteration is you repeat the same set of statements again and again till a particular condition is met. That's iteration. So you have for loop, which is like after every iteration, the value of variable or the iterating variable would be changed and would be checked against a condition. And if it meets, it would come out. Or if it meet, it would execute it again. And if it doesn't meet, then it would come out. So yeah, this is pretty much similar to other programming languages. So for int I is equal to 0, I is less than 10, I plus plus, and you write something within it. So this loop would go on for 10 times from 0 to 9. It would break, it would come out when I is greater than 9, which is 10. When it goes to 10, it would come out. While is again pretty much similar to that. You have do while construct, which is guaranteed to be executed once because the condition is checked after the execution is done once. So basically, no matter what the condition is, it has to be executed once for sure. That's when, if that's the behavior you want to put into your program, you would use do while. Execute once for sure. Jump statements, you have like break, which come out of for loop or any iterative statements. You have continue, which would again continue, and return is again coming out of a method, or yeah, mostly from the methods you return something. So the control leaves the method. Now, just to give you what if else is, if the condition is true, then execute the conditional code. If the condition is false, come out of the execution or come out of the conditional code. Skip the conditional code. That's what if else is. So here you have int I is equal to 10, int b equal to 20 if I is less than b. So it's pretty much similar to the ternary operator that we had. So you could see here tr is equal to a plus b. So basically the value, if a is less than b, which is in this case, a is equal to 10 and b is equal to 20. In that case, you would have tr as 30 since it is true. So basically it checks the condition, and if the condition is true, it executes the code with it. Now let's talk about if else. If else construct is nothing but you have a else set of statements to be executed when the condition doesn't succeed. So in this case, if a is less than b, tr is equal to a plus b, else tr is equal to b minus a. So in this case, it was less than a is less than b, so you got the value of 30. Whereas if a is greater than b, we have again changed it. So if a is greater than b, then tr is equal to a plus b, else tr is equal to b minus a. So in this case, a is less than b, so which means tr should be b minus a, which goes into the else condition statement. And here you have 20, b as 20 and a as 10, which is 20 minus 10. So you should have tr as 10. So here it's pretty much same. It does the same thing nested if else. Now we are talking about the switch statement. So you have switch expression and you would have case written against it, whatever case you want to execute. So basically you would have for value 1. So yeah, what we are trying to say here is we have a switch expression and we have a value. For value 1 as its value, then execute this piece of code and then break out. And if it has value 2, then execute this piece of code and then break. If it doesn't match with value 1 and value 2, then execute the default cases. So one thing to note here is it's mutually exclusive. Only one of it would be executed out of the cases. Make sure you break out of all the conditions. So to the right hand side, you could see integer ch has a value of 40. Now we have a switch for 40. Now case, when the value of ch is 20, it would print case 20 executed. When its value is 30, then we would have case 30 executed. When its value is 40, then we would have case 40 executed and then break out. And if it's neither 20, 30 or 40, we would have a default case executed, which says that 20, 30, 40 not executed. So in this case, since it has a value of 40, you would see that case 40 executed as output. Iteration is nothing but it is basically iterating code. If a condition is met, the code would be executed. Until the condition is true, the code would be executed, and once it is false, it would come out of the loop. So basically it's a looping statement. So after every loop, the condition would be checked, and if the condition is true, it would loop again, and if not, then it would come out. There are three types of for loop in Java. Simple for loop, similar to C, like for int I is equal to 0, I is less than 10, I plus plus would be a simple for loop. For each or enhanced for loop and labeled for loop. For each is basically iterating on array list. Suppose you have some collection, or suppose you have array, right? You don't have to manipulate the indexes, since the typical scenario with array list is iterating through all the elements within the list. So we have an enhanced for loop wherein we don't have to actually deal with indexes. Java has come up with a enhanced for loop wherein for each iteration it would assign the value of each element within the array to a variable which could be used within the loop. So we don't have to deal with indexes, like we don't have to loop through till the size is met, till the loop through till the size of an array is met. Basically, it's all done by Java itself. We have an example which would clarify it. So simple for loop is, as I mentioned, you have for int I equal to 10, I is greater than 1, I minus minus. So it would print from 10 to 2. That's a simple for loop. Now, what's the syntax for it is for, then open up round brackets, then you have initialization, then you have a condition, and you have increment or decrement, whatever you want to do. Or you could even add up like I plus equal to 2, even that is good enough. It's like for each even number. Not even, I would say, it's like incrementing by 2. Now, this is what I was talking about. So this is for each loop or enhanced for loop, wherein a typical scenario with array is you kind of iterate through each element within the array and then do something within the loop, right? So this is what Java has made it easier for us. So basically, you don't have to deal with indexes here. If you wouldn't have had for each loop, what you would do is you would, till the size of the array is met, you would iterate through and read from each indexes, right? But in this case, as you could see, there's an array, and for each loop, the value within the array would be assigned to this variable, and you could use this variable within. Makes it pretty much simpler for us. And as I said, this is a typical thing that we do with arrays. Now, labeled for loop, it's not recommended to use this often, but still we have these constructs here. So basically, it's like go to. We can have a label of each for loop. It is useful we have nested for loop so that we can break or continue a specific for loop. Normally, break and continue keyword continues the innermost for the loop only. To give rationale behind why I mentioned that this shouldn't be used often is because it becomes very difficult to debug, right? If you dry run it, if you use these labels, it becomes very difficult to actually understand what's happening within. So we should avoid it, and all this could be done by writing a proper constructs or using simple for loop as well. So we should avoid it somehow. So basically, as per my experience, this is not a good practice to use it. So type of while loop, we have simple while loop, we have do while loop. All right. So simple while loop is first the condition is checked. If it meets, then the looping statements are executed. Whereas do while loop is kind of the statement is executed once for sure, and then the condition is checked. If it is met, then it is looped again. If not, then comes out. So this is a simple while loop. So you have condition. As you could see here, while a is greater than 1, you print the value of a and you decrement it within. Here it's a do while loop. So no matter what, you would have this 2 printed and it would be incremented. So it's 2 to 9. So no matter what, some value would be printed for sure when you use do while. Now we have jump statements, which is break is like coming out of a loop. So as we mentioned, it's the innermost loop that it comes out of. So that's what break does. If a particular thing is met, or you could write a condition for a particular loop to be broken rather than continuing it. So basically you could have like this would be more or less like you could have an infinite loop, say for example, running through. And if a particular condition is met, you could break out of it. A typical scenario where it would be used. So here you could see that you have a loop from 10, which iterates from where I is equal to 10 and where I is greater than 5, I minus minus, which we are decrementing each loop. Whereas you are saying that if I is equal to 7, we should break out. So here you can see, though I is greater than 5, you can see the loop has broken out after 8. Since the value has reached 7, it's not printing the other indexes because it broke out of the loop. So basically, this is like if a particular condition is met and you don't want the loop to go ahead, you can break out of the loop. Continue is similar. When you write continue, it goes to the start of the loop again. It starts the loop again and it skips the messages, or it skips the code that you have after continue. So in this case, you could see that we have I equal to, in case when I is equal to 5, we are continuing the loop, which means the print statement for I when I is equal to 5 wouldn't get executed since you're continuing it. So basically, as you could see, the values being printed here, you can see 0, 1, 2, 3, 4, and there's no 5 here. Then we have 6, 7, 8, 9. So basically what we are saying here is when I is equal to 5, don't execute the statement within the loop. Just continue, just skip it. Okay, so what are methods in Java? So method is if you would have written function or if you would have used any programming languages, if you want to perform some operation, if you want to do something, or if you want to do something on some particular data, you would write a method. So basically in Java, methods are defines the behavior of a class. So remember I told you a class is all about state and behavior. So methods are nothing but it defines the behavior of a class. So what are methods? A method has a group of statements. Of course, as I said, since it defines the behavior of a class, you need to have some operations done, right? So you define the operations through group of statements. It is much more used to have reusability of a block of code that minimize redundancy. So imagine if you didn't have methods, then you would have written the same piece of code again and again. Say, for example, you have a method which adds to number, right? And if you write the piece of code to add to numbers directly into the main method, if you want to write it again, or if you want to again add two numbers, you will have to write the same piece of code again in the main method. Whereas if you have a method, what you would do is you would refactor and take this add method or a functionality which adds to numbers into a method. And this method could be invoked from anywhere within the application, which is nothing but reusability, right? Rather than writing the same piece of code, now what you're doing is you are defining this add method into some other method, which could be called anywhere within the code. So that's about redundancy. That minimizes redundancy and increases the reusability of a code. A class can have multiple methods, as you could imagine. You could have multiple behaviors introduced into a class, which means that you would potentially have multiple methods within a class. A method returns a null or a value using the return statement. So basically, the intent of the method is to perform some operation, right? So what the method would take is it would take parameters and do some operations on these parameters, and it may or may not return something back to the calling program. So if you don't want to return anything, you have to return null. Or if you want to return some value, you could have, say, for example, you want to return string, you would return a string of a method. You could have void as well, which means that the method is not returning anything back to the calling program. It is doing something within itself, and just the control would be back to the calling program, but it won't return anything out of the method. That's about method. So let's talk about, so what's the syntax of method? So the first one that you see, so this is a method which is public int edureka integer a integer b, and it is just concatenating the two strings or two numbers that we have sent across. So basically, let's anatomize it. So what is public? So public is nothing but again a access modifier. So public means this particular method could be accessed from anywhere within the application. So that's what public means. Similarly, you could have private, you could have default scope, or you could have protected scope. So public is accessible anywhere within the program, private is within the class, default is within the package, and the protected is within the subclass and the package. Okay. What is this int? It is nothing but the return type. So this particular method is going to take two arguments and do something and return integer, right? Name of the method is, you can see Edureka, that's the name of the method. Okay, so what you see within the parenthesis after the method name is nothing but the arguments that this method takes. So what this particular method is doing is it is taking two arguments which it is acting upon, right? So it takes integer a and integer b, that's the parameter list. So whenever you want to invoke this particular method, you have to pass arguments in this order. Now, what you see within this curly braces is nothing but the behavior, or this is how you introduce a behavior to the class, or this is how you add functionality to a method. So what you are doing here is kind of adding these two numbers. So what is a return statement? What does it do? So return statement is nothing but you do something, you take the arguments whenever control comes into a particular method, it does something and you return it back to the calling program. So the return statement is a control flow statement that terminates the execution of method and return control to its caller. So when return type of any method is void, then the method does not return anything. If it is void, you won't return anything out. But if it is returning string or something, you would return string, or null if you plan not to return anything. It could be null as well. So here we can see a method by the name work, which is returning void. So you can see that it is not taking any arguments as such or parameters, but it is just printing out saying that Edureka welcomes you. In the second case, you can see it is returning integer. So it's taking int a and b, okay, and then it is printing out and it's returning integer as well. So let's write a program, sample program to add two numbers, and we would be writing all this logic within a method. So let's start off by defining a class. All right, so we define a class, say com.edureka. And a typical name for all arithmetic operation, class with all arithmetic operation would be calculator, right? So I would write it as calculator, for example. All right, so here you can see the naming convention again. There's a package, which is com.edureka, and you have a class as calculator, and it follows camel casing. So it starts with uppercase, followed by lowercase. So you can see the class is being created here, okay? Now what we are trying to do is you are going to have a method which takes two number, okay? So say I define, let's keep it public. All right, so this is an access modifier. We want to keep it public, so we want to access this particular method from anywhere within the application. So I'm keeping this public. So typically addition would return results, right? You would add two numbers and return results of two numbers. So that's your return type, which is integer. So you could either write the return type as primitive or you could write it as a wrapper class. So basically wrapper class is nothing but integer has its own, everything in Java has to be realized in terms of classes. So integer has its own class. Int is a primitive data type and integer that you see here is a class corresponding int. So let's put the return type as integer and add is the method name. Okay. Now this takes two arguments, integer arguments, which is arg1, and let's put the second one as arg2. All right. So we start and end it by curly brace. Okay. Now we have to write logic within here. So what you see here, it's throwing an error saying that you are not returning integer out. There's a missing return statement because in the signature, this is known as method signature. This particular thing that you have defined here is method signature. So in the method signature, you have mentioned that this particular add method is intended to return integer out of the body, but still you haven't returned integer. So basically to get rid of this, I could put return null, which means it's doing nothing. Now you can see that we got rid of the error, right? So let's do one thing just to make it more verbose. I'll write integer result is equal to arg1 plus arg2. So this is a method body that you are defining here. So you are adding a behavior, right? You're giving behavior to the calculator class. So by defining add method, this certain behavior that you are introducing. Now you could have a multiply method as well, which would take two numbers and would multiply it, which is again giving some sort of behavior to calculator. So that's the reason we say that methods add behavior to the class. Okay. So here it is taking two arguments, arg1, arg2, adding it, and we will return the result from here. All right. So this is a method that you have defined. But so far, we are not invoking this method, right? We are not calling this method. We want to call and check whether it's running as expected. So that's where we would have main method. All right, when you type main, it should give you suggestion saying that are you trying to write main method. So once you click on it, it would. This is done by IDE, by the IntelliJ. Similarly, in Eclipse, you would get an option. It would give you a suggestion saying that do you want to introduce main method. All right. So we have a main method here. So again, it's public static void main, and it's taking arguments here. All right. So remember I said static and non-static method. You can see here add is non-static method. When it's a non-static method, you have to create instance of this class to invoke it. So basically, first thing that I do is I create instance of calculator. So how do you create instance of calculator? It's with new keyword. All right, you create new and it would create instance of calculator. Now I give a call to add method, and suppose I want to add like 10 and 30. Okay, so these are the arguments and it has to be in order. In this case, since both are integer, it doesn't matter. But had it been some other data type, you have to ensure that, say for example, I write string here. What this would return is typically a result, right? Addition of two numbers. Now let's print it out. System.out.println. This is for printing result of addition is. Let's print out the result that we get here. All right, and let's end it by semicolon. So basically you have a package defined here. Within the package you have calculator, and actually it's my bad. I should have defined it right here. So it gives the right package name here. So earlier I had defined calculator within com.edureka. Again, I defined a package com.edureka, which is not required. So yeah, you can see here package as com.edureka, which is nothing but the namespace. We have public class calculator. So public is nothing but the access specifier for this class. Class is the keyword used for defining class, and calculator is the name of your class. Also, one thing to note is the name of the Java file should be same as the name of the class. So that is something that IDE or IntelliJ would do it for you. You just have to create class and it would create class. So basically, if you go to the source folder, you would have something like calculator.java. All right. Then you have public method, which is again, here's the method that we have defined. Public is the access modifier for this method. Integer is the return type. Add is the name of the method. It's taking two arguments, arg1, arg2. Within the body, you are adding two numbers and you are returning result, which is integer, which aligns to the signature that you have put here. All right, in the main method, just to check whether this add method is functioning properly, what you do is you create the instance of calculator, you add two numbers, you pass two numbers to it, 10 and 30, and we are going to print the result and see if it returns as expected. So here basically it should print the result as 40 since adding 10 and 30. So remember, while it builds it, it would compile into a class file. Okay, the .java file would be compiled if it's properly written. If it's syntactically correct, it would create .class file. All right, let's wait for it to run. Okay, so it's prompting me errors that we have in other methods. So let me do one thing. Let me delete the other classes that we defined yesterday. So I go to the source folder, com.edureka. So I'm just deleting these classes that we defined yesterday. so that we don't spend time in actually correcting it. All right, so put it into a backup folder. All right, so okay, so we have only this calculator class now. I run this. So yeah, you can see here it has printed result of addition is 40. So basically what it has done is adding these two numbers, 10 and 30. All right, so that's what we have here. So we're adding two numbers. So let's talk about the sequence of how all this is being carried out by Java, right? When you run a particular program, how things work out. When you run a class, the first thing that's been called is the main method. Okay. JVM is nothing but Java Virtual Machine, which runs the program for you, which is part of JRE, Java Runtime Environment. When you run a particular class, it would search for a main method. And if it doesn't have a main method, then it would give you an error saying that a class can't be run. So it's pretty much similar to an executable file, right? So if you're trying to run a class, it has to have a main method, or you won't be able to run the class directly. So that's where the execution starts from. That's the entry point for your program. Okay. So once it encounters main and everything is good, your JVM would start executing the statements that are there within your main method. Okay. So in the addition case that we saw within the main method, we created the instance of calculator and we invoked add method, right? So when we ran that particular class, you could see that the addition was done. So basically what's happening behind the scenes is, JVM would execute the sequence of statements that you have within main. So again, coming back to the example, add example. So within the main, you invoke the add method, right? When you invoke add method, the control would go to the add numbers method and it would again execute whatever functionality you have put within that particular method. This case, it was addition of two numbers, so it would execute it. Once the execution is done, it would return whatever is being written out. So in this case, ours was addition of two numbers. So it would return addition of two numbers back to the calling program. So your calling method was the main method wherein you called this add numbers from. Okay. So it would come back to the main method and that's how it prints it out. So following the invocation of add numbers, you could see that we have printed out the result that comes out of this add numbers. And that's how it gets printed onto your console. So that's the sequence of execution that happens behind the scenes. Now, what are the ways in which you could call a method? There's call by value. Call by value is nothing but instead of passing the memory location, it passes the value of a particular variable. Okay. So this is similar to call by value and call by reference that we have in C. Okay. Instead of passing the memory reference or instead of passing the reference, it's just a value that's been passed. So if you change something within the method, or if you change the value that's been passed within the method, only the local copy would change, whereas the main copy would remain as is. But basically, call by value is just passing the value, but not the actual reference. All right, so to understand call by value, so this would give you some idea. So say for example, I have integer arg1, which is equal to 10, integer arg2, which is equal to 30. Okay, now I pass arg1 comma arg2. So what's happening here is it's passed by value. So suppose you change, so what I'm trying to say is here, if you change arg1 to something else, say 100. Okay, so what we are trying to do here is we are trying to pass this to arguments arg1, arg2 to add method. And within the add method, we are changing this arg1 to 100. Basically, we would check whether this 100 is being reflected in arg1 here. Okay, arg1 here would change to 100 as well. Let's see what happens here. Okay, so I print it, okay, before passing it by value. So I print arg1 here. Okay, and after I give a call, I will again print it. Printing arg1 after passing it a value to a method, add method. All right, so let's run this. So basically, since it's passed by value, arg1 would remain as 10. Okay, so that's what pass by value is all about. So here you can see arg1 before passing was 10 and arg1 after passing was again 10. All right. So the change that you made here doesn't reflect here. So that's passed by value. All right. So there's one more concept of method overloading. So within Java, you could have same methods with different number of parameters. Same method, when I say same method, it has got a same method name, which would take variable number of parameters. Okay. The overloading happens at the compile time itself. So during compile time, JVM understands to which method you are actually giving a call based on the actual parameters that you pass on. So just to give you a fair idea about this, I define one more method, say add, which takes say integer arg1. Let's keep this add as. So I define three parameters here. So instead of two, I define three parameters here. This is nothing but method overloading. All right. So here I define arg1 plus arg2 plus arg3. All right. So we sum it up here and we return it back to the calling program. So one thing to note here is it's not giving you compile time error, right? So you can see that it has accepted this add method as well. So you can see here the signature is pretty much same. Only thing is we have one more extra parameter, which is arg3. So it is treating these two methods as a different method. That's what method overloading is all about. Suppose I define one more arg3, I say 40. All right. So we have three parameters here. I am giving a call to add arg1, arg2. If I put arg1, arg2, the first add method would be called. If I have one more arg3, now the second add parameter or the second add method would be called. So let's define result from new add method, right? So here we say, okay. So as I said, we have overloaded the add method. Overloading is nothing but same method name, but different arguments or different number of arguments. Or it could be different types as well. You could have only two arguments, but one is integer and one is something else. Say for example, string, that also works. So basically different data types, same number of arguments, but different data types or different number of arguments. All right, so here we are adding three numbers and let's run this. So it's going to add 10, 30 and 40, which is nothing but 80. So this is done at the compile time. As I said, this linking is done by JVM at the compile time. So here you can see result from new add method is 80. During runtime, you can see that it invoked this particular method and not this one. All right. Now let's start off with arrays, right? What is the concept of arrays? So again, this is similar to other programming languages. Arrays are nothing but grouping data or grouping values of same data type. Okay. So arrays are used to solve the problem of storing multiple elements of the same data type. Okay. An array is group of like typed variables that are referred to by a common name. So you define a name.
Hello, hello, hello.
some specific index and get element from that particular index. So we would be looking at the program which would give you a clear idea about this. But basically array is nothing but group of or its multiple elements of the same data type. Array type is fixed and cannot be changed. Java, when you give the number of elements,
hello,
760, 70, and 80. That's a value that's been stored into this array. Okay. We can access
hello, 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 hello,
which is nothing but new. New keyword is used to create a particular array. All right. And here we are defining array of size 5. So this is one way of declaring.
external. Hello, 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 hello,
Now it should give you a exception. So in Java, exceptions could be nothing but caught and you could do something with it. So here you could see that it gave you array index out of bound exception since 5 doesn't exist at all. The index 5 doesn't exist at all for this array. Okay, now let's define multidimensional array, write a code to find the length of row 0, right? So let's define a multidimensional array. All right, so we have a multidimensional array here. So how you define multidimensional array is something like 1, 2, 3, 4. All right, so this is a multidimensional array that you have. Okay, so we have defined a multidimensional array. The size of this array would be 2 by 2, right? 2 by 2 is the size of this array since you have two elements here, or let me put it to remove the confusion. Let me put it this way. So right now we have like 2 by 3, right? So you have like 2 columns and 3 rows. All right, so now let's print. Actually, it has to be 3 by 2 rather. Okay, now let's print the size of this array 0, right? So how we do it is again println. Now you have multidimensional array and you have 0. So zeroth one refers to this 0, 1, and 2. Okay, dot length. So as you could see here, that individual row that you have within multidimensional array itself is an array. It's a single dimensional array. So multidimensional array is nothing but it's a array of a single dimensional array. Okay. So let me print here size of first array. I missed plus. So as you could see here, there was an exception. And since there was an exception, you won't have this particular statement executed since there was an exception here. So basically, to execute this particular statement, you should handle this particular exception. But we are not talking about handling the exception yet. So I'll have to comment this to pass through. So now you could see that it has printed out 2, which is your size of first array. So this is a program that we actually did right now. Create an array having many characters, write a program to copy elements from created array to another array, and also write a program to delete an element from an array. Okay, so I'll just talk about this right here. So we have an array here of characters, right? So basically when you want to delete something from an array, what you will have to do is you will have to shift the indexes, right? You can't delete something directly from an array. So what you will have to do is if you want to remove something, then you will have to shift the indexes. What happens is suppose you have an array of 5 integers and suppose you are deleting the second element, right? Now what you would do is you would shift, if you are deleting the second element within the array, you would shift all the elements that follows the second element to the left, right? So the third element would become the second element, the fourth would become third, and the fifth one would become the fourth. So basically you shift it. That's how you delete something from an array. All right. So other thing is about copying elements from the array. We have a utility class, which is nothing but system. System is a class itself. So as you could have seen that when I'm printing out something, I do system.out.println, right? So this system, it's a utility class in Java, wherein it exposes a lot of functions within or a lot of methods, utility methods within. So one of them being array copy. So here you have to give source and the starting index and the destination. And what we are trying to do here is copy 5. So this is how we copy from one array into another, starting from index 0. So this is copying. And the other one that you see here is about delete. So as I said, deleting is nothing but we have a logic written here to shift the indexes to the left. So here we are trying to delete one at index 3 and we are just shifting elements after this index 3 to the left. That's how we delete something from an array. Now let's see what are strings. So string is nothing but again, it's a data type within Java. So why do we have strings at all, right? We have array of characters. Then why do we have string at all? So here's an example wherein you have a lot of loads of data. So you could imagine a role of a data analyst who has to analyze through a lot of data coming in, right? So nowadays it's like petabytes of information being processed throughout a day, right? Which would be very difficult to handle if you had to deal with character array. So that's where Java has come up with strings, which is nothing but a group of characters, but you don't have to deal with it. Java by itself has a class which would take care of this strings. And since strings are widely used within a program, you could imagine that name or anything, that any identifier that we have is mostly we have to store it as the string. So one of the data types that's widely used within industry or which is widely used in programming is string, right? So Java has some kind of string management as well to make sure that programs run or make effective use of strings. Okay. So here what's been mentioned is James is a data analyst and he's finding it really difficult to actually deal with character array to store patients' names every time. So that's where we have string. So string is solving the problem of actually dealing with character array. So Java is actually having character array is storing characters or the characters in the string in a form of character array, but it doesn't expose it to the outside world. You can just use this class to deal with it, but you don't have to deal with character arrays. So Java string is nothing but sequence of characters. They are objects of type string class. Once a string object is created, it cannot be changed. This is a immutability functionality of Java, wherein once you write to it, you can't change the value. So this is specifically important when it comes to multi-threading, when you have multiple threads accessing a particular string, a same string. So that's when immutability helps us to make sure that multi-threading is it's thread safe. We call it as thread safe because multiple threads can access the same string just because it is immutable. All right. So what are different ways in which you declare a string? So you have string str is equal to new string, which you are not initializing the value of the string here, which could be any value. And you have string str1 is equal to edureka, wherein you are initializing the value of the string right away. The other one is the character array. Similar to the integer array that we discussed, we have character array as well. So immutability of the string. So why do we have immutability? One is for security. So string stores a lot of useful information, like even the credentials and stuff like that, which shouldn't be accessed by external users. So this immutability factor of string helps us to keep it secure so that no one else can see it. Synchronization. So this is what I spoke about. When you have multiple threads accessing the same string, you don't have to synchronize it. Java by itself, through its immutability feature, would ensure that multiple threads can access the same string without hampering it, or it would run as it's expected. Caching. So caching is nothing but you have a string pool. So basically, if you have two strings with the same value, it won't store it. It won't store redundant copy of it. There would be just one copy in the string pool, and both these references would be pointing to that value. If you happen to change one of these references, it would point or it would create a new value in the string pool and point the other reference to it, sort of. So basically, what we do is why caching is required is, as you could imagine, in an application, as I said, string is widely used data type, and you could have multiple references pointing to the same value of a string. So we don't want to have duplicate values stored. That's where this caching comes into picture to utilize memory efficiently. So what is string pool? As I said, string pool is all the constants that you define within the string within the application would be stored in the string pool. String pool used in Java is a pool of strings stored in Java heap memory. So we have heap memory wherein the objects are created, and that's where string pool resides as well. String pool is possible only because strings are immutable. You can't change once it is defined, you can't change it. If you change it, then you can't change that particular memory location. It creates one more entry in your string pool, and the reference would point to the new entry. So the actual memory location is not getting changed. That's what immutability is all about. String pool helps in saving a lot of space for Java runtime. We are breaking on the redundancy factor here. So if you have multiple strings, or if you have multiple strings holding up the same value, it won't create multiple copies of it. There would be just one value in the string pool, which would be accessed by all the references. So basically, string pool, as we discussed, is or resides in heap memory. So string is not a primitive data type. Unlike character, char is a primitive data type. String is not a primitive data type. It's a wrapper class to array of characters, right? And this is specifically done so that Java has a mechanism to manage strings well, which is widely used data type within any application or any programming language for that matter. Java strings are stored in string pool of heap area, which we already discussed. So we can see a string pool. So we have stack memory and heap memory. So when you have a local variable, when you define something locally, the reference is created in the stack, all right, and it points to the actual object is created in the heap, but the reference is created in the stack. So you could see S pointing to hello in string pool. Okay. So S is nothing but a reference to the string. Okay, so here we can see that we are concatenating, right? So this would give you a fair amount of idea what immutability is all about, right? So here we have string S1 is equal to happy, all right? And what we are printing out is the original string that is happy, right? So you could see here S1 is a reference that's been created in the stack. You have a string pool within your heap memory, which would store all the strings, all the constants or literals that you have defined here. So you could see happy been stored in the string pool and S1 pointing to it. Now you are trying to concatenate S1 with learning, right? So it's happy learning. So you could see that the memory location that S1 is pointing to is not changed, right? It's still pointing to happy. But there's one more constant that's been created in the string pool. That's a concatenation of happy and learning. So you could see happy learning also created. But what's important to note here is S1 is still pointing to happy. It's not pointing to happy learning. All right. So if you want S1 to actually point to happy learning, this is how you do. So you have S1, which has the value happy. All right. So you do S1 dot concat learning and you assign it to S1. All right. So you are assigning to the same reference as S1 and you are printing out S1. In this case, what would happen is, unlike the previous example that we saw, wherein S1 is still pointing to happy, you would see that S1 is pointing to happy learning. So here you could see that S1 is pointing to happy learning. So basically you move the reference from happy to happy learning. All right. So let's see what are strings. How do we operate on strings, right? So let me create a new class here, just string demo. I create a main method again. All right. Now what we do is string s is equal to Eureka. All right. So let's first print the length of the string. All right. So this is how this utility class, or this is how this wrapper class helps us. So it has all these utility methods, right? You just have to do s dot length. It would give you length of the string. So had we not had strings, and if you want to deal with the character arrays, you would have to print the size of the array here. All right, so when we run it, it should print 8. 8 is the size of the string at Eureka. Let's have substring. So it's a beginning index. So suppose if you give 2, so it would give you substring from index 2. So basically we are getting substring. we are getting part of the string. Substring is nothing but part of a string, right? From a particular index. So since we have given 2 here, it starts from index 2. So you have 0, E is at 0, index 0, D is at index 1, and U is at index 2. So it starts from U till the end of the string. You have compared to, you could define 2 strings and you could actually compare them and see the value. So basically, so you could have one more string defined here, something of this sort. All right, so here we compare it. So we are doing s1 dot compare to give s2. So we are comparing s1 with s2. So it compares the given string with current string. So here you can see it has shown -1, right? Since B is 1 ahead of A. So if you have same string, it would show you 0. So if it's exactly the same, it would give you 0. You have is empty. Suppose you don't have anything within your string, you could check it whether it's empty. Is empty returns a Boolean variable, which means if it's true, it is empty, and if it is false, it has some value within. We have 2 lowercase, we have 2 uppercase. In this case, suppose you want to, there could be scenario in which you want to change or you want to change the casing. So I'll just take one of it. I make it 2 uppercase. Okay, so S1 is nothing but we have edureka stored within, and we are, so when I run this, you should have edureka printed in uppercase. So here we have it in camel casing, and let's see the output. So here you can see the string was converted or translated into uppercase. So similarly, you could do lowercase, which would print string in lowercase. Now we have value of is nothing but the value of a string, value of some of the data types. So you could pass integer and you could do value of, and it would give you a convert integer into string, right? So value of is a method within string which takes different data type and converts it into string. So just to give you an example, you could have like integer I is equal to 100, string dot value of, and you give I, it's converting this I into string. So it would print the same value 100, but it's converting it into string. You could replace something within the string if you want to replace particular character within the string, which could be done with replace method. So replace method takes 2 parameters. Replace is a method within string which takes 2 parameters. First one is the character that you want to change, and the second one is the new character that you want to change replace to. Okay, so here to show s1 dot replace, I could replace E with E maybe. All right, so we are making it lowercase, and as you can see here, it's printed in uppercase E was changed to lowercase e. So that's about replace. We have contains, which again gives you Boolean type result, which says whether a particular value or particular character is present in a string. All right, so in this case, we check whether we have S2 with HELDO, and you replace D with L, which becomes hello. And now we are checking with the replaced string contains D, which it doesn't contain it, right? So it would give you false. So that's about contains. Equals is basically checks for the equality of string. It takes one argument and it compares it against the string object against which you invoke the equals against. All right, so to give you an example, so you have S1, which is edureka. Now to print it, so here we do S1 dot printing equality of string. So since it's the same, it would give you true. If had it been different, it would give you false. So you can see here it's printing both the strings are the same. You have different methods like compare, ignore case, wherein in this case we compared with case, right? If you would have had Eureka in lowercase, right? If it would have started with lowercase e, you wouldn't have got 0 here, all right? Whereas there's one more method which is s1 dot compare to ignore case, wherein it doesn't consider the case, right? So even if there's a case change, if there's a one in uppercase and one in lowercase, still it would match, or still it would give the value as 0, which means both the strings are the same. We could get some character out from a string. Okay, there's a method character at. There's ends with, which again returns a boolean value saying that whether a string ends with a particular character. All right, so here what we are doing is we are checking whether the string p, which holds the value happy learning, is ending with u, which doesn't, right? That's the reason it gave you false. Had it been g here, it would have given you true. Now that's about strings. Now let's talk about different variant of strings and why do we need it. So there are like three variants of string. One is the string class itself. The other one is string buffer, and you have a string builder. So we'll talk about why do we need these variants at the first place. So string buffer is nothing but it's good for multi-threading. When you have multiple threads, usually it's good to have string buffer because all the reads and writes that you do on the string, it is synchronized. So when I say synchronized, there's only one thread that could access a particular method within a class at any given point. So you can't have multiple threads going in and changing the value or doing something. So basically, if you have a string within your application which is being accessed by multiple threads, it's better to go with string buffer. Or if there's a lot of not accessed as such, access is one factor, but of course, if there are a lot of modifications done and stuff like that, like with string buffer, you could append to a particular string, which cannot be done in string, right? In string buffer, you could actually do a lot of things which cannot be done in string. And just to make it thread safe, they have made all the methods that modify the string contents as synchronized so that only one thread can access it at any given point. So see, you can see insert here, right? In string, you don't have all these methods. You don't have methods to manipulate the strings in string, right? Whereas in string buffer, you have methods to manipulate the strings. So when I say strings, those are literal strings, right? Not the string class. All right, so here we have string buffer and we are trying to append something to the string buffer. So we define a class, we define string buffer. So you could have like s1 dot append, and when you see append, you could see that it appends any data type. This is the important factor in string buffer. You have a lot of utility methods within, or you have a lot of methods to manipulate the string, which you don't have it in string class. All right. So this is mutable, right? You're changing the values. Suppose I append 3 exclamation marks to it, right? So what we are doing here is we are just printing out the new string. All right. So basically you should see Edureka and the 3 exclamation marks. Yeah, as you could see here, it got appended. Right? So basically it's a mutable string. Change the value within. Insert is nothing but inserts a new character at the given position. So here we are saying that insert W at position 0. You could replace particular or replace substring with a new string. So here what we are saying is replace index starting from 0 till 2 with this new character sequence. You could delete something from it, delete sequence of it. So here we are saying from index 0, delete one character. So if you have 2, then it would delete 2 characters. So basically, when you say 2 characters, even this E would have been gone. Okay. In this case, we are just deleting one character. So basically, this delete method takes the starting index and the number of characters following the starting index. Reverse, you have like you could reverse the entire string. Okay. So just to show you, I can new string dot, if I reverse it. So basically, these are kind of utility methods which we often use, right? So you can see it's been reversed here. All right, you can see the capacity of the string. Capacity of the string buffer is nothing but I think it reserves 16 characters initially when you declare it, and it keeps on incrementing it. So it has a growth factor defined within, which you need not take care of at this point, which you need not think about it at this point, because those are internals to Java. But initially, when you declare a string buffer stores space for 16 characters, which is 32 bytes. If you have string buffer, why do we have string builder, right? So string buffer, as I said, has some drawbacks. What are the drawbacks is more about string buffer is synchronized. When I say synchronized, which means that only one thread can enter it, only one thread can process it. So basically, if you have a multi-thread application, you should go with synchronization, because synchronization has some overhead, right? It has its own trade-offs. So when you use synchronized, what happens is when you move out of the synchronized methods, JVM internally has to do some operations which takes some time. So basically, it's good to avoid synchronization, and which would make the application much more faster. And that's where string builder comes into picture. If it's a single threaded application wherein you know that you don't have multiple threads which are going to access a particular string, in that case, you should go with string builder as against string buffer, because string buffer would give you a slightly lower in performance compared to string builder. Most of the things that string buffer does is done by string builder as well, as far as the functionality is concerned, but it's not thread safe. String builder is faster, but it's not thread safe, which means that you cannot have multiple threads accessing it. All right. So to keep it simple, if you have multiple threads accessing a string buffer, then you should go with string buffer. But if you have a single threaded application, you should go with string builder, which would make the application much more faster than string buffer. Again, with string builder, the default capacity is 16. When you initialize it, it stores, as you could see, it allocated 16 space for 16 characters initially. So as far as the demo is concerned, it's pretty much similar to string buffer. As far as the outcome is concerned, it's pretty much similar to string buffer. There's no difference as such. But as far as the performance is concerned, string builder is faster than string buffer, because it's not synchronized. Okay. So you define a string builder with happy and you append learning to it. Okay. And if you try to print SB1, which is appended with learning, you will see happy learning, would see it being appended. Okay. Similar to string buffer, when you delete character from index position 0 and one character from that position, you would see that the edge, which is the first character, has been deleted out. So you could see that at index 1, you could insert welcome. You can see the entire string, that is welcome, being inserted between. Okay. Then you have reverse. You could reverse the entire string, pretty much similar to string buffer. So again, this one is pretty similar. You are appending, you are deleting, then you are inserting here, you have reversing here. This is pretty much similar to what we did for string buffer as far as the syntax and semantics is concerned. And the outcome is the same as well, just a performance change in terms of speed, right? So when to use string buffer and string builder? As I said, if you have multiple threads, you should go with string buffer to make it thread safe, but it would be slower as compared to string builder. Okay. String builder is specifically good enough when you have single threaded application, and it would be faster since it's not synchronized. So to make it thread safe, you have synchronization, which adds over it to the performance, which takes toll on the performance. That's why string buffer is slower. Why to use object oriented concepts? So let's talk about classes and objects. So classes are nothing but it has got a state and behavior, right? As you could see, you have a class and you have different objects, right? There's a phone which is a class and which has got different types of phones, right? A rotary phone, then you have a touch tone phone, and you have a cellular phone. These are objects basically, right? So you define phone, which is pretty much generic and which has got state and behavior. Class is something that is generic, that has got state and behavior. But objects is something that is an instance of a class which would have specific state and behavior. So phone by itself, phone is a class by itself, which may or may not have specific behavior. But you could see that the specific phones will have its own behavior. You could define its own behavior. So all these three things that you see here, three types of phones are nothing but objects, objects of phone class. State is something that is defined by instance variables, right? It's a class level variable, right? At the class level, you define something that gives state, and behavior is nothing but something that is defined by methods. Like calculator was a class wherein we had a add method, and add method basically gave some behavior to the calculator class, right? So what are attributes? So you have a class and you have attributes. Attributes are nothing but a property of an object. And in Java, this is defined by your instance variables. Basically, class will have properties, which is nothing but the state, which would be defined by instance variables. And you could imagine every instance will have its own set of properties. It won't be the same, right? In terms of the phone that we saw earlier, there were three different types of phones. You could imagine that it would have different properties, right? It's not the same. So what are the naming conventions in generally used at the industry level for Java? So this is not something that is actually taken care by compiler. So even if you don't follow these naming conventions, still the compiler would pass through. But these are best practices, or this is good to have thing in the industry. Conventions is more about to keep everyone on the same page and make it easier for other developers to understand more, right? Or keep things simpler. So that's why we have conventions. If we wouldn't have conventions, then people would prefer to write in their own way, which would make us difficult to understand. All right, so for class name, it should start with uppercase. As we saw in all the examples, you would see that I have always used started with the uppercase, or it's rather camel casing. So in this case, you could see string buffer demo, right? So it starts with uppercase. You have B, which is again uppercase. You have D, which is again uppercase. This is nothing but camel casing. It starts with uppercase. Basically, it follows camel casing. Interface name is again similar to class. It starts with uppercase. You have method name, which should be lowercase always, which should start with lowercase, but you could have it follows camel casing, but it has to start with lowercase. So main is a predefined method within Java, right? So you could see main starting with lowercase. Or I created add, right? Add is again, you could see uppercase. If you would have, say, for example, add numbers, you would have something of this sort, add numbers. So if you want to append numbers to it, it should start with uppercase. So basically it's camel casing, but starting with lowercase. Whereas class name, it's a camel casing which starts with uppercase. Variable name is again camel casing, which should start with lowercase. And constant is always like it has to be everything in uppercase. So basically, if I define a constant final string, I would write something like this. Okay, so and if you want to add more words to it, it should be like this underscore. So it should be separated out by underscore. All right, so these are the conventions that's followed in industry by Java community. So mostly, even if you go to the source code, if you want to see something, dig into the source code of Java, you would see same naming convention being followed. Types of variables, we spoke about the types of variables. Again, to brief you through, we have local variables. Local variables are nothing but the variables that are defined in a method. So if you define something within a method, that's local variable. So arg 100, or suppose I define int local var is equal to 100. So this is a local variable, right? If you remember, this is within the scope of a method. Once the control goes out of a method, your variable is no longer accessible. And also it gives space for the JVM, for garbage collector, to kick in and clean up this particular memory space. Instance variables are nothing but it's defined at the instance level. So here, for that matter, this constant is also instance variable. All right, so I can define integer. Variable starts with lowercase and it follows camel casing. So this integer is nothing but an instance variable. It's at the class level, right? When your class is loaded, when you refer to this particular class, you would have your instance variable initialized by Java. So instance variables are declared in a class, but outside a method, constructor, or any block. Okay. Class variables are nothing but static variables, and it is one copy per class. So as against instance variable, which is one per object, whereas static variable or class level variable are it's just one per class. So if you define static, this is just one per class, and this could be accessed directly using calculator dot constant example. You would be able to access it. But for instance variable, you need to have an object created. This is non-static, basically non-static instance variable. So one of the reasons why you need to access instance variable is because different instances might have different values for a particular instance variable, right? I could define calculator 1, right? Or let me put it as calculator, and we have like normal calculator. You could have one more class which is like scientific calculator. That's one more object. Now normal calculator can have its instance value as 10, and scientific calculator can have its instance value as 100. You have different values, but whereas in static, since it's one per class, it's not at the object level. So you have demo d is equal to new demo, which is an instance of a class demo, and you print message, right? D dot print message, and it should print this message. So basically there's a class demo which has got a method print message, and we are trying to invoke that message from the main method. Okay, let's talk about the constructor. Constructor is nothing but when you invoke new keyword, new calculator, there's a constructor, implicit constructor for each class, which is without any parameters. So we'll talk about that. But when you do new calculator, basically there's a method which could be used by the programmers to initialize variables. If they want to initialize something, so for each instance, if you want the same value for an instance variable, you could initialize it within constructor. So basically constructors are for initialization, or if you want to do some kind of pre-processing, right? On invocation, if you want to initialize something or do some kind of pre-processing, that could be done through constructor. Constructor is used in creation of an object. It is a block of the code used to initialize an object. So when I say initialize an object, it's nothing but initialize some property or variable within your class. Constructor must have the same name as the class it is in, and it does not have any return type. So unlike method, which has got a return type, constructor won't have a return type at all, because what we are trying to do through constructor is just to initialize objects within, but you can't return something out of it. So basically constructor is a special method which you don't have control over. You're not doing anything within it. You're not trying to actually return something out of it, right? You don't have control over its invocation. It's done by JVM itself. JVM calls a special method when you invoke new, or when you create instance of it by using this new keyword. Constructors are of two types: default constructor and parameterized constructor. So when I say default constructor and parameterized constructor, this is nothing but, so I'm defining a constructor now, calculator. As I said, it has to have the same name as the class. Okay. So this is a constructor. And as I said, this could be used for initialization of variables. Say I initialize this to 200. So for all the objects, you would see this being initialized to 200. That's the initialization. Okay, so I have created two instances of it, two instances of calculator class, that is normal calculator and scientific calculator. Let me do normal calculator dot instance variable. Okay, so here we are printing the value of the instance variable. Let me copy the same thing again, but in this case, the second case, I would be, as you could see here, we have a constructor. I defined a constructor here, constructor for a class, which is initializing the instance variable to value 200. So as and when you call this new calculator, a new instance of calculator would be created. The first thing that would be called is this constructor, and which would initialize it. So basically what we are trying to do here is, we are right after the construction of this particular object, we are going to print the values of instance variable to see if it assigned 200 to it. So here you could see the value 200 being printed out. So basically, if I wouldn't have constructor, then the value wouldn't have been 200. So let me comment out this one. This is how we comment in Java, by the way. This is a block comment which starts with slash and asterisk, and which ends with asterisk and slash. So I commented out that one. I commented out the constructor, and you would see the value being initialized to 0. So you could see value being initialized to 0. All right, so that's what constructor is all about. Now this is a default constructor. You could have parameterized constructor, which is like integer, you provide some value, right? And you assign this value to variable. So instead of hard coding this value of 200 for the instance variable, you could pass on some value during the construction of the object. So basically what we are doing here is, I pass 30 here and I pass 40 here. All right, so I'm passing 30 and I'm passing 40 to the constructor. And as you could see here, we are initializing the instance variable to that value. So basically for normal calculator, it should be 30, and for scientific, it should be 40. Yeah, as you could see here, you have 30 and 40 being printed out, and this is the parameterized constructor. That's what this default and parameterized constructor, and that's what it is all about. So default constructor is, you don't even have to specify any constructor. So I commented this calculator constructor. Still implicitly there's a constructor put in by JVM, which is the default constructor. So it's not mandatory to have constructor each time unless you want to initialize something. So what's the difference between constructor and a method? Constructor must not have a return type, whereas method may or may not have a return type. Here you could see that unlike the methods add integer which return something, this doesn't say anything. This doesn't return anything because we are not doing anything within it. We are just initializing it, initializing some instance variables, right? Constructor name must be same as the class. So this is a contract. This has to be followed. Constructor has to have same name as the class. Since you are not invoking the constructor by yourself, it's done by the JVM. You don't have control over invocation of constructor, and you have to follow the naming pattern that Java recommends to, or Java forces us to. You have to make sure that constructor is given the same name as the class name, whereas method can have any name. As we saw the add method, you are free to use whatever method name that you want to. Constructor is used to initialize the state of an object. We saw the instance variable being initialized within the constructor. Method is basically, it gives some behavior to a class, right? We saw add method, which is giving some behavior to the calculator method, which is nothing but adding up to numbers. Similarly, you could have multiply, you could have divide and stuff like that, which adds more behavior to it. Constructor is invoked implicitly. So you don't have control over invocation of constructor, which is done by Java itself. When you try to instantiate a class or when you use the new keyword, it's implicitly invoked by Java, by JVM. Whereas method, you have to invoke it manually. So basically, when you do this, constructor is called by itself. Whereas when you want to call add numbers, you have to invoke it explicitly. How does constructor work? The moment object of a class is created, the constructor of the class is called, which initializes the class attributes, right? So we saw about this. So when you use the new keyword, JVM by itself would give a call to the constructor, which could be used for initializing instance variables within your class. So type of constructors, there's default constructor and there's parameterized constructor, which we already spoke about. The constructor which is created by the compiler without any parameters is the default constructor, and the constructor with specific number of parameters is called parameterized constructor. So here we spoke about this already. So we have integer value, right? This is a parameterized constructor since you are passing parameter to the constructor. Whereas if you don't define anything, Java by itself. So in this case, you could see that we didn't have a constructor for this class, right? Array demo, we don't have constructor for this class. So Java by itself puts a default constructor for array demo, which is known as default constructor. So it's not mandatory that you need to have constructor every time since Java takes care of it. That's the differentiation between default constructor and parameterized constructor. We use parameterized constructor for passing values to the constructor and initializing something based on the value that's been passed in rather. So the default constructor is used to provide the default values to the object like zero, null, depending on the type, right? When I didn't have any constructor at all. For a moment, I'm going to comment this. So this is a line comment. When you put two slashes, it's a line comment. Okay, it's commenting just this particular line. There's a block comment and there's a line comment. Block comment is slash asterisk and ends with asterisk slash, whereas line comment is two slashes, forward slashes. Okay, so basically, I'll comment out these constructors as well. All right, now we have this calculator class. Now let me print the value of the instance variable. Value of instance variable initialized by default constructor. All right, so we don't have a constructor at all. So that's what I'm trying to say here. I commented out these constructors, right? So we don't have a constructor at all. And when you create a new calculator, JVM by itself would have a default constructor, which is used by JVM to initialize variables within. So you would see this instance variable as value as zero, because that's what the default constructor does. It assigns some value to it. It has like specific values. For integer, it's zero. If it's a class, it would be null. So you could see the value being printed as zero. If it's a class, it would assign value null. So in this case, you have string, right? And you could see zero, null, depending on the type of instance variable that we are dealing. We saw how we passed parameters and initialized it. Constructor overloading is just like method overloading without return type. Constructor overloading in Java is a method of having more than one constructor with different parameter list. Like we defined add, we had two add methods, and now I have renamed this to add numbers, but basically this was add method, right? So you could have multiple methods with the same name but different parameter list, which is known as overloading. Similarly, for constructor, you could have the same paradigm. So basically what we are trying to do here is we have a constructor with one parameter that's integer. I'll define one more constructor here with two parameters. So we define one more parameter here, and I say, for example, I put something like this. So we are adding up these two parameters and putting it into instance variable. Okay. This is constructor overloading. So here you have single parameter being passed, here you have multiple parameters being passed. So based on whatever you pass here, suppose I say 10 and 20, or say I say, so on construction, you should see 130 as the value of the instance variable. Okay, as you could see here, you have the instance variable initialized to 130, which is nothing but addition of 110 and 20. And you could have something like this, just 110, which is also okay because you have a single this thing defined as well. Constructor taking a single value as well. And in this case, it would be just 110. So constructors are nothing but methods which helps in construction of an object. All right, so you get 110 here. So constructor overloading is in Java is a technique of having more than one constructor with different parameter list. So we had a demo about it. As I showed, there were multiple constructors, one with one parameter and the other one with integer parameters. And during runtime, based on whatever you pass, a particular constructor would be called. In this case, you could see that in the first case, which is shop S1, you could see the first constructor being called, which has two integers as being passed. Whereas when you create object S2, which has two integer parameters and one string,